Welcome back everyone to this lecture on basic recurrent neural networks. We're now going to explore how to use recurrent neural networks on a basic time series such as a sine wave. Before we jump into the actual notebook of Python, however, I want to quickly discuss what the actual sequence batches can look like when you're dealing with time series data or just sequence data. Let's imagine we have a very simple time series, just the numbers 0, 1, 2, 3, all the way up to 9. What we end up doing is we want to create an actual data point that we can train on and then predict and compare our prediction to a label. So essentially what we do is we separate this out into two parts. So here we've separated out into a training sequence shown in green for the numbers 0 through 8, and then we want to predict the next sequence value. In this case, the sequence value that we're trying to predict is essentially just a label. What's the next number going to be? So we feed the green parts into our network, and then we say try to predict, and its prediction is then compared to the correct sequence value, which is 9. So keep in mind, we can actually usually decide how long that training sequence should be, and also technically we can also decide how long that predicted label should be. So the sequence doesn't need to be all the numbers right before the very last number. For example, here we can see a training sequence of the numbers 0 through 4, and then we're trying to predict the next 5 numbers, 5, 6, 7, 8, 9. So we have a lot of flexibility here as far as what the training sequence is and what the predicted label should be. Also keep in mind that we're going to feed in batches of these sort of data points. So we can also edit the size of not just the training point, but as well as how many sequences to feed per batch. Here we can see a single batch of time series sequences. And in this batch, we have 3 data point entries, where we have a training sequence per data point of 4 numbers. So the first one is 0, 1, 2, 3, and then the actual label we're trying to predict is just a single value. What's the next sequence value? So we're trying to predict 4. And then given the numbers 1, 2, 3, 4, try to predict 5. Given the numbers 2, 3, 4, 5, try to predict 6, and so on. So again, lots of flexibility and a lot of things you can edit here. You can edit how many time series sequences you're going to provide per batch, how long the actual training portion, that green portion, should be, and also how long that red portion, the label, should be. So given how much flexibility we have over this, how do we decide how long that actual training sequence should be? Keep in mind there is no definitive answer, but it should be at least long enough to capture any useful trend information. So what do I mean by useful trend information? Well, for example, let's imagine that we're dealing with seasonal data. Here we've plotted out a seasonal data set that shows airline passenger counts through the years 1949 and 1960. And this actual data set is monthly data, which means there's 12 points per year. And if we take just a general look at this data set, it definitely appears to have some sort of seasonality component to it. It looks like it's going up and down throughout the years, and that's really due, if you take a closer look at this data, that people have summer vacation and they tend to travel more during the summer months, and then we can also see correlated peaks to the kind of winter holidays like Christmas or New Year's. So there's definitely some seasonal trend. And that sort of domain knowledge and experience, and also just exploring the data set using tools like pandas, can lead you to understand the minimum size of a training sequence. So if this is monthly data, we should probably include at least 12 months in the training sequence so our network can learn the pattern of a year of data. So given this data set, we would say include at least 12 months of data or more. You wouldn't want to just include 5 points because then you're not actually being able to learn the entire pattern of a year and the seasonality of a year. Again, there's no definitive answer, and a lot of this is domain knowledge. So this often takes domain knowledge and experience, as well as just simply experimenting with different training sequences, different numbers of time series per batch, and using some sort of metric like root mean squared error to measure the error of forecasted predictions. Now, typically, a really good starting choice for the label is just one data point into the future. Now, how do we actually forecast with recurrent neural networks? Let's again imagine our data is 0, 1, 2, 3, all the way up to 9. And we've decided that we're going to train it on sequences of 4 points to predict the next point. And what we want to do now is we want to actually forecast into the future. So I want to try to predict points beyond that last number 9. How do I actually do this, since I'm only predicting one time step ahead given my actual training sequences? Well, our forecasting technique is to predict a time step ahead and then incorporate our prediction into the next sequence we predict off of. So let me just walk you through a quick example. The first thing we would do is we look at the very end of our time series and we grab a batch that matches what we actually trained on. So since we trained on 4 elements in our time series to predict 1 element into the future, we end up grabbing the very last 4 in our total time series, and then the network ends up actually forecasting a prediction into the true unknown future. So no longer are we actually trying to compare to some sort of test set. In this case, we don't know whether or not 10 is the right answer, since we're now forecasting into the unknown future. So this is different between a train test split and then comparing our test results. Now we're actually forecasting into the unknown future, and there's really no way to tell how off we are with the number 10, especially if our data doesn't have some sort of clear pattern to it. You can get an intuition of how far off you are. For example, here we can clearly see the pattern is add 1 as you go along, so 10 doesn't seem to be a ridiculous prediction. So we can kind of evaluate it that way, though we really don't know whether or not 10 is 100% correct for the forecast prediction, since this is unknown data. And then what we want to do is, let's say we want to actually predict maybe 4 time steps into the future. We keep predicting further by now including our forecasted prediction into our batch and essentially dropping that 6. So then we take that, pass it through our network, and grab another forecast prediction. And then we grab that one, drop what we already know, and now we're basically forecasting on our forecasted values. So you keep repeating this process, and you can keep repeating this as far as you want to go, but keep in mind, and I've kind of shown it here, that the further you forecast out, and then you're forecasting on forecasted values, and you go further and further, the higher likelihood you have that your forecast predictions are going to start to deviate or start varying widely. And that's because you're forecasting on forecasts, so any minor error is going to start getting magnified as you go further and further along. I've tried to show that here by, instead of getting just 11, then we get 11.2, then 12.4, then 14 instead of what should probably have been 13, etc. Again, we don't know for sure if 11.2 is actually wrong, since we don't know the true values here, since we're forecasting into the future that we don't really know. But essentially here we've completed the forecast, and we do this again by grabbing our predicted forecast and including it along with the data we know until we get a complete forecast. And if you want, you can repeat this process as far out into the future as you want. So let's go ahead and explore this further with Python. And we'll do this by opening up a Jupyter Notebook and running a basic recurrent neural network with a sine wave in the very next lecture. I'll see you there.